All right, friends and neighbors, time now for another networking video. What we're going to do this time is fool around a little bit with Packet Tracer, and we're going to build a small topology, and then we're going to build on it a little bit to sort of work through some of the concepts that we need to build these slightly larger topologies. So the first thing I'm going to do is bring a bunch of PCs onto the board. Maybe like that. And then we'll bring some devices. And I'm grabbing everything from this sort of menu down in the bottom left. And I'm going to put a router right here in the middle. And then we'll add maybe a couple of switches. Now I'm sort of crowding to the one side here because we're going to open up some other windows. So maybe what I'll do is rearrange this a little bit. And so what we have is a couple of networks, or we're going to have a couple of networks. We've got to get everybody connected here. So I obviously need my connector tool. And so I'm going to grab this guy here and go from the PC fast Ethernet. We'll go down here to fast Ethernet 1. Whoops. We need another connector. Fast Ethernet 0, and we got to go to fast Ethernet 2 here, and then we'll also go from fast Ethernet 00 over here to the router. We'll go 24 just to put it all the way at the bottom. Now we can see our arrows here sort of indicate what's happening with our connections. This looks really down here. This looks sort of up, sort of down. I don't know what's going on, but the switch is figuring out that there are PCs out there. And then we'll also do a connection to the other side. Fast Ethernet 01 is coming over here. I like going to 24 again. And then we'll do this. All right, so we're getting all connected, but we really don't have a very functional network at this point. So I'm going to come over here to this PC. And I'm going to go to configure. Now I know that I'm going to make my router my default gateway eventually, and the default gateway address that I like to use is that one. And on the fast Ethernet side, I'm going to go 192.168.1.1. So what I'm doing is I'm going to make the 192.168.1.0 networks and the 192.168 2.0 networks. And we can see that by default on PCs the interface is up. So now we come over here to this config. This guy's on the same network, so it'll have the same default gateway, but of course a different IP address. All right, and that should do it there. PCs should be happy. Now, if I come over here and I open up my simulation tab, I can go simulation or I can go real time. And before we do that, what I'm going to do is I'm going to edit some filters here because there's some things that I don't want to see, at least in this particular demo. So the miscellaneous things that I'm going to get rid of, I'm going to get rid of Cisco Discovery Protocol and STP. They're necessary protocols. They're part of most topologies. Well, CDP obviously is Cisco specific, but STP should be out there. And so I'm going to get rid of those two guys because they're just going to clog things up a little bit for today. Now the other thing that I'm going to do is right now I'm going to come in here to my router, and I could configure this in much the same way, right? I can go down here to these interfaces, but I want to use the router CLI. And so there's a little tab expansion, a little more tab expansion if you want to use it. And what I'm going to do is go to interface F0/0. That's my fast Ethernet connection on the left-hand side. And I'm going to give it an IP address. And the IP address that I'm going to use is the default gateway IP address that I chose on my hosts. Now on a router, the interfaces are not up by default. Whoops, there we go. They're not up by default. So in a CLI, I could check that box, or in a CLI, what we do is we say no shut. Oh shoot, we'll get rid of DTP too. Let's see, where are you? TTP, we don't want that either. Okay, so now what I'm going to do is I'm going to grab a particular host here. And when I say I'm going to go to the desktop, I'm going to go with a command prompt. And we know with that we can do our IP address, right? If I wanted to get the MAC address, I can grab the MAC address right there. And these are good things to pay attention to, because as we generate traffic, what we're going to be doing is looking at source and destination MAC addresses, source and destination IP addresses. And what I want to do first, let's take a look at one of our tables too that's important to us. Our ARP table. Now in this case there are no ARP entries found, and so that's actually good for us, because when we do this simulation I'm going to be pinging between these two hosts, and I want to sort of think about what's happening here. And maybe we'll try it both ways. We'll do so first up we're going to ping 192.168.1.2, so that's just the other host on my network. And we can see that on PC0 I've got this ICMP and the ARP queued up here. And we're sort of waiting to see what happens. Now let's see what happens if we go to real time just for fun. Oops. Well, that sort of screwed that up, didn't it? All right. Well, I guess I don't want to mess around with Windows while I'm doing things. But if we look at what we've got going on here, let's hope Camtasia's okay. All right. If we look at what's happening here, I've got packets flowing on my network over here, and the addresses that are being used, right? If we look at the PDU itself, we can grab the source and destination MAC addresses here, and then we got the source and destination IP addresses, and that's one of the things that we want to be aware of. Now, one of the other things that I'm worried about, let's see, what do we got over there? I think I'm okay. All right. So one of the other things that I want to be able to do is make sure I can ping my default gateway. Well, actually, before I do that, let's do something else. Pinging the default gateway is certainly something that I would want to do when I was doing some testing. But let's work on our host configuration first. So now this host will be 192.168. This is on the 2 network, right? The other side. And its gateway will be 192.168 2.254. Now a good question is, where is 2.254? Well, it's right here on the router, but we haven't configured it yet. So I'm going to go to the other fast Ethernet interface, and I'm going to go IP address like this, and give it a mask, and of course no shut. All right, so now if we look at our simulation here again, and I'm on this PC, the big question is, what happens when I ping that host on the other side? What tables do I use? What addresses are used in the ARP request? What addresses are used in the ICMP echo? So there it goes. So we can see that it's queued up over here again, right? And if I look at what the PC is thinking about doing, it says, who am I going to ARP for? Well, this is me, but take a look at that target IP address. Why am I ARPing for the router? And the answer, of course, is that I have to talk to the router to get off of my network, and that's the key. So what we see here, whoops, is an ARP for the router that goes out, but the ICMP message, of course, is between the 2 original source and destination IP addresses that are part of this. And there it goes right there. And we should see that once, eventually, what happens is it gets to the switch, then it gets to the router, and then the router will forward it to the other side. But there's also a little other magic. What is that? Oh my goodness, that's an ARP that popped up there. What is that? Well, it looks like the router is trying to find the destination MAC address of PC2 so that it can finish this particular transmission. So that's what we're looking to find out. It's what we're looking to understand. Now, I guess it's worth noting that on the router, I can look at what my router knows in terms of tables too. So I can say, well, show me your routing table. And this routing table shows me that this router is directly connected to two different networks, and each network is attached to a particular interface. But a router also has an ARP table. So the router has to learn how to build Ethernet frames to send to the destinations just like a PC does. Okay, very good. Well, let's expand our network a little bit. I'm going to drag this guy down here. And we're going to add another router. And then maybe we'll add another switch. Okay, so what I'm going to do is I'm going to connect this router. Whoops. I'm going to connect this router right here to this particular switch right here. And we'll go ahead and use one of these other connections here too. Now notice that these two routers are both connected to this switch. And everybody on this switch, I haven't given this guy an IP address yet, but everybody on this switch has a particular network. That's the 192.168 2.0 network. So now what we'll do is we could go ahead and give this router a connection to the switch, and then maybe we'll add a PC to this side. We'll put him up here with the rest of the PCs. Okay. So what I'm going to do is take a look at my networks. I've got a network over here. I've got a network over here. And now it looks like I've got a network over here. So on this particular host, what we're going to do is give it an IP address like this. The 3 network. And so its default gateway would also have to be on the 3 network. Okay. Well, where is that? Well, that's probably right here. But in addition, this router is connected to the 2 network. Okay. So let's go ahead and configure our router. Do you want to enter the initial configuration dialog? The answer to that question is no. Let's see. Go config int 0/0. Now, well, actually, let's do int f0/1 first, because that's sort of the easy one to figure out. This is my new network. And what that should do is bring this interface on this side up. And if I go to this particular host, and I do ipconfig here, I can see that I've got my gateway. So let's try to ping that gateway to see if it's alive and well. We see that we're trying over here, and it looks like we've got some happy communication here. Hopefully this works, and we'll pull up our... Now, as we're processing the tables, every once in a while you get a timeout like this. But we'll just wait here a second, we'll see what happens. Oh dear. So it doesn't look like the switch wants to bring this up yet. All right, so while we're waiting for that, we're going to finish our config on the router. And so this router is connected to the same network that this router is. So a good question is, what would be the IP address that we would use up here? And so if I go over to that interface, we got everything slowing down because of the simulation. It's got to be on the same IP or the same IP network as all the other hosts. Buffer full. Okay. All right. Thank you. So we filled the buffer up. That's pretty awesome. So I'm going to go and I'm going to say, well, if it's on the 192.168.2 network, but I need a different router. So let's do 2.253 instead of 254. And then we'll also do no shut. Okay. Now, if we take a look at our show IP route, we know that this router is directly connected to the 2 and the 3 nets. And this router, whenever you're ready, whoops. There we go. Is connected to the 1 and the 2 nets. So now the question is, how in the world do we tell these two routers about the 2 networks? So the problem is, this router knows about these 2 networks, but it can't get over here. And router 0 knows about these particular 2 networks, but it can't get over here. And so the way that we solve this problem is with the IP route command. So what I would do is I would say IP route, and I'm going to use this as my static routing command to get this router to understand where the other network is. So what network are we looking for? We're looking for the 3 network. The mask for the 3 network looks like that. Now, here's the tricky part. Where do I send this traffic to get to the 3 net? Well, the answer is router number 1, but this interface on router number 1. So it's going to be 192.168.2.253. And that is the proper way to do an IP route statement. And so now if I look at my routing table, take a look at what just changed here. Now all of a sudden I know about all 3 of the networks. I know about these 2 directly connected networks, and I know about this network via this static route. Well, what about this guy here? We have to solve this problem too on this router. So now what I would do on this router is I would say IP route. The network that I'm looking for is the 1.0 network. It's not an IP address, it's the 0 network. There's the mask, and then the forwarding router's IP address would be this one right here. And so I would say 192.168.2.254. So the 2 router, the interfaces in between are communicating with each other. And we'll go ahead and hit enter and show IP route. And there we have it. There's all 3 of my routes represented here. Now, one fun fact is that you can also communicate from the router. I'm going to try something here. Let's do real time. All right. You can also ping from the router. So I can ping, say, my neighbor. Here's a good test to do. And again, we've got our switches that are acting a little funny here. And we'll try to get a little help here. We'll try to wake everybody up. So he can ping 2.254. Let's try 253. There we go. So they're alive and well. There we go. They finally are talking to each other. There we go. Okay. And so now the real test would be, can I ping all the way across? And so what I might do is ping. Now this is 3.1, and if I want to ping all the way across, it will be to 1.1. And there we have it. It gets all the way across. Now another handy tool for us to use is traceroute. There we go. And this tells me the path along the way. There's some more details to that, but there you have it. Well, I think that'll about do it for this video. We'll dig into some more details later on Packet Tracer and how things work. But for right now, this is networking. You can do this.